Alright guys, in today's video we're going to be looking at linear functions. Okay? In our first example, what we're looking at is we're just trying to determine, does it represent a linear function? Well, how do we know if it represents a linear function? What we are looking for is we were looking for what we call the same first difference. Okay? Meaning if we subtract our values here for y, and we have a step of 1 each time here, 1, that we get the same value every time. So if we look at our first step here, 11 to 17, well, how much did we go up by? If we do 17 minus 11, we get 6. From 17 to 23, we went up by 6. From 29 to 23, we went up by 6. And from 29 to 35, we went up by 6. Okay? So we have the same first difference of 6. So the answer is yes, it is linear. All right? Let's look at another example. Let's look at our second, example 2 here. All right, so again, we're seeing, does it represent a linear function? Well, our change in the x each time is still just 1. And if we subtract and see our change here, well, now we're going the opposite direction. We're going down by 1.5. So we're subtracting 1.5 each time. Okay, we subtracted 1.5 here. But as we get to this step here, when we do our subtraction, 11.5 minus 14, we actually get negative 2.5. And here again, we get negative 1.5. Well, if you look here at this value, this one is not the same as the others. So the answer would be no, it is not a linear function. All right. So once we've determined whether it is a linear function or not, the next step we can do is we can actually find what that linear function would be. Okay? So if we look at example 3, first off on example 3, we're looking at our changes in x here. Well, our change in x is 1 each time. We're going up by 1. And then we look at our change in y. We want to make sure it's the same each time. So if we do 10 minus 7.5, we get 2.5. 12.5 minus 10, we get 2.5. 15 minus 12.5, we get 2.5. And 17.5 minus 15, we get 2.5. Okay? Well, our linear functions, if you remember from Algebra 1, are written as y equals mx plus b, where m is the slope and b is what we call the y-intercept. Okay? Well, to find m, we simply take the change in y over the change in x. So our m here would be 2.5. To get our b value, we have to do a little bit more work. Our b value is going to be where x is 0. Okay? Well, you notice we do not have a x value of 0. The lowest we have is 1. But if we took one more step back, a difference of 1, and we went to 0, we could find that. Well, we're adding 2.5 each time, so instead of adding 2.5, we subtract 2.5 to work backwards. We will find a y value of 5, because 7.5 minus 2.5 is 5. So that means our b value is 5. So to write our equation, we simply just plug our m and b in. Y equals 2.5, x just remains x, plus 5. Okay, so let's look at another example that's a little more complicated. Example 4 here. The reason it's a little more complicated is, notice our change in x now. Well, from 2 to 4, we're now going up by 2 each time. Okay? And let's look at our change in y, our first difference. 21 minus 22 is negative 1. 20 minus 21 is negative 1. 19 minus 20 is negative 1. 18 minus 19 is negative 1. Okay? So when we find our m value, we do the change in y over the change in x. So our m value is now negative 1/2. Our b value, okay, well, we're going by 2's, so if we took 2 more away from this, that would put us at 0. So let's do the same step we did over here, negative 1. Well, what could we subtract 1 from to get 22? The answer is 23. So our b value is 23. So now we're going to write our equation. It's y equals negative 1/2 x plus 23.